Hi, 8th grade. Welcome to your first lesson of Topic 7, Understand the Pythagorean Theorem. By the end of the lesson, I want you to be able to say, I can use the Pythagorean Theorem to find unknown sides of triangles. Kelly drew a right triangle on graph paper. Kelly says that the sum of the areas of squares with side lengths A and B is the same as the area of a square with side length C. Do you agree with Kelly? Explain. Well, what they mean is there's a square side lengths A, a square side lengths B, and a square side length C. We can agree that the black square is bigger than the blue square and the orange square. But she's saying that the blue and the orange ones added together would equal the black one. So we're going to try it. Say that this was 3, this one's 4, and this is 5. So A equals 3, B equals 4, and C equals 5. So A squared, the area of the triangle, or the area of the square of A, is 9. 4 squared is 16. And 5 squared is 25. So we got 9, 16, and 25. So she's saying that 9 plus 16 equals 25. And it does. So that checks. Sam drew a different right triangle with side lengths A equals 5, B equals 12, and C equals 13. Is the relationship Kelly described true for Sam's right angle? Well, let's try it. 5 squared is 25. 12 squared is 144. And 13 squared is 169. So is 25 plus 144 equal to 169? Yep. That works. Kelly draws another right triangle. What would you expect to be the relationship between the areas of the squares drawn on each side of the triangle? I would say the area of the largest square is equal to the sums of the areas of the smaller squares. Example number 1. Understand the Pythagorean theorem. Triangle ABC is a right triangle with lengths A, B, and C. What do you think when you think logically and use definitions, properties, and given facts to construct an argument? You are developing a mathematical proof. The hypotenuse, C, is the longest side of the right triangle. So that one is always C, the one across from the right angle. Then these are A and B. It doesn't matter which one. This could have been A and this could have been B, just as long as C is the hypotenuse. Compose a square using 4 copies of the right triangle. Write an expression to represent the area of the large square. So we have 4 of these triangles that are exactly the same. And we need to do area. Area equals 1/2 base times width. Area equals 1/2 base times height, or in this case, our base is A, our height is B. And there's 4 of them. That's why we have over here 4 times 1/2 AB. Then we also have this square in the middle that's just made of C's. So area is length times width, C times C, or C squared. So we add that to the equation. Then rearrange the triangles inside the same square and write an expression to represent the area of the large square. So again, now we have a different square, but it's still the same size. So we have these rectangles that's made up of 2 triangles. And their area is length times width, so AB. And there's 2 of them. So AB plus AB, which gives us 2AB. Then there's the small square that's just made up of A's. So A times A is A squared. And lastly, this bigger square with side lengths b, b times b, that's b squared. Okay, now 4 times 1/2 gives us 2ab plus c squared equals 2ab plus a squared plus b squared. But if you see, both sides have a 2ab. So we could take the 2ab out, and we have c squared equals a squared plus b squared, which is the Pythagorean theorem. A squared plus b squared equals c squared. That's the formula you're going to be using for a right triangle, where c is always the hypotenuse, the longest side. Try it. A right triangle has side lengths of 15 centimeters, 25 centimeters, and 20 centimeters. How can you use the Pythagorean theorem to write an equation that describes how the side lengths are related? Remember, the only one we care about is the longest one is c. The other two can be a and b. So a squared, 15 squared, plus b squared, 20 squared, equals c squared, 25. Get out my calculator. 15 squared means 15 times 15. So that's 225. 20 times 20 is 400. And 25 times 25 is 625. So that works. 225 plus 400 equals 625. How do you know that the geometric proof of the Pythagorean theorem shown above can be applied to all right triangles? Well, we just showed it with a proof. We just showed it with variables. So since the proof works with variables, it will work when you substitute. The only time it will not work is if it's not a right triangle or you put A, B, and C in the wrong place. Example 2. Use the Pythagorean theorem to find the length of the hypotenuse. So this is when we don't know what C is. So we have to solve for C. So we plug in this 8 for A and 15 for B. 8 squared is 64. 15 squared is 225. Add those together, we get 289. To get C by itself, to get rid of the squared, we have to take the square root of both sides. So the length is 17. Use the Pythagorean theorem to find the length of a leg. So here we have C, the one across from the right angle. We have A, we just don't know what B is. So we plug in 20 for A, 20 squared is 400. Plug in 29 for C, 29 squared is 841. To get B squared by itself, I need to get rid of that 400. So the two 400s cancel out. And B squared equals 441. So you take the square root of both sides. So B equals 21. Mara needs a 21-inch piece of trim, so she does not have enough trim to repair the display case. Try it. A right triangle has a hypotenuse length of 32. It has one leg with a length of 18. What is the length of the other leg? So we don't know B, we have C, we have A. So A squared plus B squared equals C squared, write the formula. Substitute what we know, 18 squared, I don't know B squared, and C is 32 squared. 18 times 18 is 324, plus B squared equals 32 times 32 is 1,024. Subtract 324 from both sides. This cancels, and we're left with B squared equals 700. Got to solve for B, so you got to take the square root. But if we take the square root of 700, it's an irrational number. So they said just to leave it as a square root. B equals the square root of 700. Key concept. The Pythagorean theorem is an equation that relates the side lengths of a right triangle, a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. So the one across from the right angle is always c, and these could be either b or a. All right, 8th grade, let's say it. I can use the Pythagorean theorem to find unknown sides of triangles. Have a great day.